The new articulator is based on an idea method derived from the category of uniqueness and diversity, and corresponds to the virtual kinematic axis method. This video is illustrated using CATIA. The articulator employing the virtual motion axis method presented here is not entirely different from conventional ones. What is different is the structure of the regulatory mechanism for anterior and lateral movements. The adjustment mechanism for the condylar and incisal portions of conventional articulators is made up of mechanically rotating and sliding parts that are combined to create a guide surface. The new articulator allows the guide surfaces of the condyle and incisal paths to be made by cutting resin blocks with a 3D modeling machine or by laminating resin with a 3D printer. This means that it is free from off-the-shelf mechanical adjustment mechanisms. The guide surface can be made precisely and in any way the user thinks fit. What has traditionally been buried under the word accidental can be unearthed at the discretion of the user. The advantage of the resin-formed method is that it is not bound by existing methods and can be easily customized by the user into an organic shape. If a simple, geometric shape is acceptable, as in the past, the user can simply form the guide surface that way. Structure of centric latch Part 1. This articulator has a unique structure. The left and right fossa boxes are removable, and the hinge movement is possible even when the fossa boxes are removed. Many conventional articulators have a structure in which the left and right condylar balls are fixed by pressing them against the side wall of the fossa box by the force of a plate spring. The new articulator has a unique structure that allows for hinge movement even when removed, as the fossa box is removable. Hinge motion is a rotational movement around the axis of the left and right condylar balls. This articulator possesses an independent rotary axis mechanism since there is no mechanism to press the condylar ball of the mandibular frame against the fossa box by the force of the plate spring. Therefore, the upper and lower articulators are not split when the fossa box is removed, allowing for hinge movement. This image shows the upper and lower frames locked together to prevent splitting. Only the left side has a fossa box, but hinge movement is still possible in this state. This image shows the rotary axis of the upper frame of the articulator retracted and unlocked. Once the lock is released, hinge movement is no longer possible. The lower frame of the articulator becomes free, allowing the condylar ball to be guided by the walls of the fossa box for anterior and lateral movement. This is how it is structured. Structure of centric latch Part 2. Hide the cover at the bottom of the centric latch. Change the display method from shading with material to shading. You can see the inside of the centric latch. The left and right rotary shafts are independent. A spring is inserted inside the rotating shaft so that the force is always applied to the outside. The lever can be moved in a U shape. The lever is constantly being forced backward by the lever cover. A spring is set at right angles to the axis to apply force toward the rear.